Let's start with Redox. The person who asked for basic conditions or acidic. The way I solve it is to go through the acidic conditions answer first, and then we'll get to the basic conditions answer. So we'll do both in this example. Do this. There we go. Whenever there's a carbon involved, you'll see two species that have a carbon. It's a little messy to calculate the oxidation state. We can try, but different carbons in organic species will have different oxidation states. So if I have you balance something, I usually, and there's carbon, I won't ask you what the oxidation state is. Okay? Just because carbon's a little messy. We might try it, we'll see how we're feeling. Alright, I'll do the easy one. This is +3. What's chromium right here? It's plus something. Well, oxygen, I'll do the other easy one. -2, -2. Oxygen's -2. That's plus what? 6. I agree. Okay. Just for fun, let's do this carbon right there. +4. Let's see what this carbon is here. Plus what, if we tried it? What do people get? Oh, it's -2. -2 plus 6. Yeah, that works. That works. Okay. What is reduced? Yeah, the chromium, and then the oxidized one, that'll be the carbon. So chromium reduces its oxidation state or goes down, literally reduces. Carbon goes up in oxidation state, -2 to +4. Again, these could be artifacts and not totally true for carbon specifically. All right, so let's try to, let me write them both down. So, I'll do them in different colors. Okay. So we'll just start with the chromium. It doesn't matter which one you do first. By the way, on my exam, and I think most instructors, if you flip the oxidation reduction state, we'll probably take 2 points off the entire problem, like a 10 to 15 point problem. Okay? All right. Step 1, balance whatever is not oxygen or hydrogen, that's chromium. 2. Step 2, balance the oxygens with water. So +7 H2O. Step 3, balance the hydrogen with what? H plus, yeah, not H2, not H. Plus 14H plus. Step 4, balance the charge with electrons. First, are the electrons going to go on the right or left? Left, how many?
11.
Is it 6? I think it's 6. Yeah, 14 minus 2 is 12. Minus 6 is 6. 2 times 3 is 6. Okay, 6. All right, that's that side. You can tell it's a reduction because it has the electrons in the reactants, which always happens for reduction. Okay, next. First, balance whatever is not oxygen or hydrogen. That's the carbon. Step 2, balance the oxygens with water. There's 4 on the right, 1 on the left. So I think we need 3. Okay, only water works here. You can't put up O or no 2. It has to be water. Okay, step 3, balance the hydrogens with H+. How many H pluses am I adding?
8.
6? 11. Whoa, 12. Oh my gosh, there's a lot of answers here. I'd go with 3 times 2 is 6, plus 5 is 11, plus 1 more is 12. Okay, and I have to add final step, step 4, balance the charge with electrons. Plus 12 minus 12 on the right equals 0 on the left. Okay, notice also oxidation has the electrons in the product. That's always true of an oxidation half reaction. Okay, let's get a different color. These are two simultaneous reactions. I need to cancel the electrons, so I'm multiplying the top reaction by 2. I think the bottom one by 1 will do it. That'll drop the electrons. Let's add this up. Okay, I gotta move this back. Okay, I'll do all the reactants first. 2, a dichromate ion plus 28. Ooh, this is good. H plus C2H5, that's ethanol, plus 3 water. Okay, that goes to, let's see, did I multiply by 2 on everything? 2, okay. Yeah. And then 4 Cr3 plus 14 H2O plus 2 CO2 plus 12 H plus. Okay, I think that's everything. I can simplify a little bit. Let's try that. What will cancel? H plus, yeah, 12 from 28 is 16, right? Okay, what else? Water, 3 from 14, I'll do that one, 11. Cool. All right, now, I want the basic conditions answer, so you need to locate the H pluses. They are right here, net of 16 on the left-hand side at the moment. So I'm going to find those and then add the same number of OH minuses to both sides. So if there's 16 H pluses, to change to basic solution, you add 16 OH minuses. Okay, let's go to the new slide. All right, so I get, how many waters will I get on the left just from this addition? 16, yeah, not 32. So, 2, Cr2O7, 2 minus, plus 16, H2O, plus ethanol. I think that's everything there. Other side, 4, Cr3 plus 11 waters, plus 2 CO2, plus 16 OH minus. Anything else cancel? Yeah, the waters do. So there's a net of 5 here. And does anything else cancel? I don't think so, so let's write our final answer. 2, Cr2O7, 2 minus, aqueous, plus 5 H2O, liquid, plus ethanol. I don't know if I gave you this. Usually it'd be aqueous or liquid. Let's see if I listed it. I listed it as liquid. 4 Cr3 plus, that's aqueous, plus 2 CO2, that's gas, plus 16 OH minus aqueous. That looks like our final answer down there at the bottom. I'll circle it. When you're reporting final answers on my exam, for sure, report state symbols. I will often ask for the half reaction, so you want the state symbols there as well. I didn't put them in. So you can fill them in for fun later tonight. Okay, any questions on that before I move on? That's a pretty classic example. I'd say like slightly difficult of a medium average question. Okay, any questions on this? Moving on. Oh, yes? Ms. Malone. Let's do net ionic, neutral. Let's do all three simultaneously. All right. Net ionic. Oh, yeah. In my class, I do this. Cool, let's do it. Okay. Who picked net ionic? Do you want the first one or second one? In my class, how you'll see this type of question is it's written out. You write the whole reaction and then get to the net ionic. I'm only grading the net ionic. So we're doing the first one. So barium nitrate. Barium is a +2 charge. Nitrate is -1, so you need 2 nitrates. Okay. Plus ammonium phosphate. Ammonium NH4 plus, phosphate PO4 3-, so I need 3 of these. Yeah, exciting. What kind of reaction is this? Yes, it's a double replacement. You see 2 ionic compounds, so you switch ions. So barium now goes with the phosphate. Phosphate has 3 and the barium is +2. And then the ammonium goes with the nitrate. There's an ammonium, and then the ammonium is +1, nitrate -1. All right, now we want to what? Balance. Let's do that. I look at the one with the most complicated subscripts first. For me, that's this one. So I go 3 barium, 2 phosphate, and then 6 here. Okay, I think that does it. Move this out of the way. All right, in my class, or anybody, what would we do next? Before that, the state symbols, then write it out. So state symbols, so get your solubility rules. I think all the classes, not just mine, will give you the solubility rules on the test. So it's not something to need to remember. Here's my version of it.
Mine too.
Okay.
Yes.
Compounds that are aqueous are also called soluble or mostly soluble, or called no precipitate. Compounds that are insoluble are solids or precipitates. Sometimes you might see the word immiscible. Well, all right. Barium nitrate, solid or aqueous? Aqueous, what bullet? 1, nitrate. So that'll be aqueous. Next one. Solid or aqueous? Aqueous going to what bullet? 1, ammonium. Okay, next one. Solid or aqueous? Aqueous, double number 1. Ammonium and a nitrate. I'm going to write the state symbols in a second. And then finally this one. Solid, what bullet? 5, the last one. These bullets, the way I wrote them, are in order of importance. So the first one's the most important, on down. Yes? Halides. Let me ask the audience, what's a halide? Halogens. So that'd be fluorine, chlorine, bromine, or iodine. So the second bullet, is that what you're looking at? Okay, yeah, let me explain the second bullet. Halides are normally aqueous. There are 3 common exceptions. A lead-2 halide, which would be like lead-2 chloride, solid. Or silver-1 chloride, for example, solid. Or mercury, is that mercury 1 or 2? 1, mercury 1 chloride, for example, that'd also be a solid. But any other cation with a chlorine would be aqueous. That's how that second bullet works. Okay, let's move this out of the way. Now, let's write these down. I said aqueous here, or you did. Aqueous, solid. By the way, this has another name besides a double replacement reaction. It is called, starts with a P. Precipitation. Because the solids in the products and not in the reactants. That's it. So double replacement where a solid is formed is called a precipitation. Just like if it snows, that's called precipitation. So snow comes out of nothingness apparently, just like this. That's another example of precipitation. Okay, so now what am I going to do? I have to find which ones are strong electrolytes and separate them out in solution. Yes or no, strong electrolyte? Yes? Yes or no? Yes? No? Yes. So anything that's aqueous ionic, I'll underline it as a strong electrolyte. Solids, liquids, gases, no good. Not strong electrolytes. By definition, a strong electrolyte separates out a solution. So that'd be, in this case, 3 bariums and 2 nitrates, 6 NH4, sorry, 2 phosphates. This separates out as well, 6 NH4 plus and 6 NO3 minus. Oh, sorry, this was 6 up there. Did all my coefficients right? I think. Okay, now you're looking for stuff that cancels. The nitrates cancel 6 and 6. Ammonium, 6 and 6. I think that's it. So now you're going to write your final answer. This is the net ionic.
Yeah.
Let's see. There's 3 bariums. All ions are always what phase? Aqueous. If it's an ion, it's aqueous. Phosphate, there's 2 of them. 3 minus. Aqueous. And barium, 3, phosphate, aqueous. Nope, solid. Solid. There we go. That would be your final answer right there. Okay. I haven't finished everything that you had asked me on this section, but any questions on this one at the moment? This would be a pretty classic example. Normal level right here. Okay. All right. The other thing that you also asked is a neutralization reaction. So let me review that really quick. Let me make up one. Oh yeah. Oh, I'm doing it right now. Okay. This is a neutralization reaction, but more broadly could be called a double replacement because you have an acid with an ionic compound, a base specifically. So when an acid and a base react, you're going to have a neutralization reaction. Neutralization forms what? 2 things. Water and salt. A salt is also called, it's an ionic compound. So anything that's ionic is also called a salt. When you're in this area of study, they call them salts. Everywhere else, called an ionic compound. Okay. So you just switch ions. The salt is this, Sr2 plus, I minus, so you need 2 I's. And then HOH, that's also called water. Water is a liquid. And, oh, look at your solubility rules for this one. What's the state symbol? And what bullet? Bullet 2, and it's aqueous. Yeah. Halides are normally aqueous except for those 3 exceptions. Okay. All right. So, ... if you did the net ionic, We already did one, so I won't do one again, but you can do this at home. You should get this answer. Oh, I didn't balance it. 2, okay. All right, you should get that answer. If your neutralization reaction has a strong acid and a base, and that base is also strong, then the net ionic always looks like this. If the acid or the base is weak, then it'll be a variation of this. By the way, how did I know that my acid, first, what's the name of that acid there? Hydroiodic acid. How do I know it's strong? It's on the table I showed you class. Did the other classes learn that?
Yeah. Yes.
Okay, I'm hearing more mumbled yeses than no's. So ask your neighbor. Okay. Let's see. There's no questions on that. I'm moving backwards to the reactions chapter.